So what happens if we change the position of a component in a simple circuit? So if we were to move one or more of the parts around into different positions, will the circuit still function in the same way? So let's have a look at that. We know that this simple circuit is controlled by a switch. The light bulb turns on when the switch is pulled downwards. When I push it back upwards, it turns the light bulb off. So that would be a description of this circuit. Well, in order to answer the question about does it make any difference where the parts are or which way they are positioned, then we'll have to change their positions. So we've got to investigate this properly and systematically. Now, if we just randomly move things around, then that's not a very scientific way to do this. The proper way to do it is to make individual changes, then observe the change, if any change occurs. And that's a proper scientific method for any investigation. So with electrical circuits, the fun for children seems to be just, oh, let's take it to bits, put it back together. What happened? Oh, nothing's happened. And you've got to learn something from when things don't happen. So we've got to do this systematically. So what do we mean by changing the position of a component? So let's do a change. Look, if we were to unclip the light bulb, now we're going to keep all the same parts. We can't go taking a part out completely and then seeing if it still works. That's something different. So let's just take that part and say, well, look, it was positioned like that. So let's position it in a different way. Look. So all I've done is turn the component round through 180 degrees. So halfway all the way around. So now the connection that was over there is now over here, and we've swapped them. You see, was it just random that that light bulb lit up? Or will it work either way around? And until you've got the answer to that, well, you don't know. You've got to pin down all of the answers to these simple questions for the children to get a good understanding of what they're dealing with, so that when things go wrong, they know what's gone wrong. Or they can give a reason for it and describe how to put it right. So let's just try it. We've swapped that light bulb all the way around. Clip back together again. There it goes. Switch was down to make it go on. Let's just give it a go. There we go. So first one ticked off. It does not matter if the light bulb is changed around through 180 degrees and we swap its electrical connections. It still functions as a light bulb. So let's apply the same thing to a switch. We could unclip a wire and swap the wire around. In this particular configuration, it's rather awkward to try and swap the battery around, but it can, it can be done. But let's try the switch first. So let's unclip the switch. Now remember, and people often miss this, that switch turned the light bulb on when it was clicked in the down position. Right, so now let's turn it on. Turn it all the way around like the last one. Look for the connections underneath. Right then. So now, by physically turning it round, the light switch lever points downwards. And now, in order to turn it on, we've got to point it upwards. So it's a subtle little change here, but the switch still functions as a switch. It still controls the electricity flowing in the circuit and lights or stops the bulb from lighting up. Right? It's controlling it. But physically, we now have a switch which works. In the up position, it turns our light bulb on, and in the down position, it turns it off, whereas before it was opposite that. If you just think about the implications to that with light switches at home, most light switches at home operate so when you click them downwards, then the light bulb in your home would turn on. So a lot of switches click downwards. And that's just, you know, to make life easier for us instead of guessing on is it up or is it down. Of course, you could look and see if the light bulb was on, but it's easier if we've got them all pointing down. Bit different for stairway lights because they're a special type of switch which function up or down depending on whether the previous person upstairs or downstairs had already operated the switch. So that's worth having a look at. So to all intents and purposes, it's only the position of the lever that's altered. The switch has exactly the same function. And then of course we could try altering the wire around that way. What else could we try? Well, we should only make one change at a time, but swapping the position of the switch and the light bulb, having already established that rotating them, you know, doesn't have a significant effect, then swapping them round, already knowing that information, that would be a useful thing to do. So we've changed the position of our light bulb, changed the position of our switch. Does that work? We'll let you find that one out. Now we've also got a buzzer to introduce. So rather than take the switch out, so maybe you can see why I'm going to do this, rather than take the switch out and overcomplicate things by either having too many parts or by swapping the item that actually controls the circuit, then it would be better if we actually substitute the light bulb. Now we could put all three of them back in later, but that's for another day. So let's hook them all up. This lot could all be recorded in a table of results to say what the changes resulted in. And now let's operate our switch. And quite clearly the switch this time is controlling the electrical current flow in the circuit, and when it passes through the buzzer, it makes a sound. So the buzzer makes a sound. Let's turn it off. Remember, if we wanted it to operate such that the switch goes downwards, we'll have to rotate the switch around in position. So everybody happy with that? Now let's not just get bored and finish there, because there's a very important thing for us to do next. Just like with the light bulb, when we rotated it round, let's make a prediction. Do we think that rotating this round and connecting it in a different way will make a difference? So let's give it a try. We often ask the children to make a prediction, and really predictions have got to be made based upon some prior knowledge. So the children have never met a buzzer before, and thinking it's the same as a light bulb would be wrong. So maybe it wasn't a good idea to do the prediction, but rather just to get a surprise. And here's the surprise. Let's just swap it back just in case we've got this wrong. Turn it round again, clip it back. So we know the buzzer works. It's just that it functions in a different way to the light bulb. It does not allow us to turn it round and connect it in that other way in the circuit. And the secret is really the people who've made the buzzer have colour coded the wires coming out of it. It's got a red wire and a black wire, and it's most common when people code things like this to code the plus connection of a buzzer with a red wire. So what we've found out is in our circuit it does not work this way around. We trace this back because the negative of the battery is at this side and there's the positive of the battery. So if we turn it around this way in the circuit where it links back to the plus side, then it will work. So let's hook it back up again. Switch it on. There it goes. And of course we could swap again and put them in those positions there. So let's have a look. Let's get it right first time this time. There's the plus of the plus connection of the buzzer. We know that's the plus of the battery there. So these two have to be joined together. So when you do, if you were to allow children just this free investigation of electrical circuits where they just connect anything to anything, half of them would tell you that their buzzer doesn't work. It wastes an awful long time, and you know it's time we could be spending learning the basics a bit better and moving on to greater things. So this systematic way of going through the components one at a time is absolutely the best way to do electricity. It means that you establish a series of ground rules about how these components work and special ways in which they function, such as the buzzer, and you can get on to the more interesting things to do with designing circuits to suit particular functions for a particular job, like alarm circuits and that sort of thing. So after this, what we'll do is maybe look at in more detail at the function of a switch, which is a fundamental part of a circuit, and then how on earth maybe we can invent our own switches.
Fabulous.